Hey guys, what's up? So today we're going to be looking at simultaneous equations. Okay, guys? Wow, that's kind of really thick. Yeah, we're going to be looking at simultaneous equations, right? And simultaneous equations are a system of several equations with several unknowns. Often the equations in the system are linear, right? So for an example here, we have 5x plus 3 is equal to 21 and 2x plus 2y is equal to 20. So we have two unknowns. We have x as an unknown and we have y as an unknown, right? There are even simultaneous equations, guys, with three unknowns. Usually they put a z as an unknown, right? But for most of CXC, guys, we're just going to be looking at two unknowns, okay? And it says here, simultaneous equations are equations that have the same solutions. Cool. Yes, they definitely have the same solution. So once we find this x and y, they should be the same, right? They wouldn't be different. And the equations are all satisfied by the same values of the unknown quantities, right? And simultaneous equations can be solved by the method of elimination and the method of substitution. So we're going to look at these two methods now, guys, and we're going to jump right into it. Cool? So the first one we're going to look at is the method of elimination. Cool. So let's look at it, guys. All right, guys. So we're back in it here, and we're going to be looking at the method of elimination. Cool. So the first thing here, and the most important thing, is elimination. Cool. We're going to eliminate in order to find the unknowns. And it says, in using the method of elimination, we make the magnitude of the coefficients of one of the unknown values equal in order to get rid of it, right? When the signs of the equal coefficients are both the same, both positive or negative, then we subtract one equation from the other. And that makes a lot of sense. Okay, so there are two ways to eliminate. One, focus on the y coefficient, and two, focus on the x coefficient. All right, so let's look at an example here, guys. The same example, and a similar example to what we had earlier. Let's say we have 5x plus 3y is equal to 21, and this of course is the first equation. Then we have 2x plus, this is a 2, plus 7y is equal to 20, right? And this is the second. So the first thing we're going to do, guys, is we're going to focus on the y coefficient. No, actually, guys, the first thing we're going to do is we're going to focus on the x coefficient. Okay. I should have probably had x here, but it's no problem. Let's do 2 first, and we're going to focus on the x coefficient first. Cool. All right, guys. So we're going to focus on the x coefficient for elimination here, and we're going to write back the same equation we had before. We're going to look at 5. Whoops. Let's reduce the size there. That's really big. And we're going to look at 5x, right, plus 3y is equal to 21. And this is equation 1, right? Then we have 2x plus 7y is equal to 20, right? 2x plus 7y is equal to 20. Cool. All right, so the first thing we want to do here, guys, is we want to find the LCM of the, right, we want to find the LCM of the x coefficients, right? So we want to find the LCM of these. So we want to find the LCM of 2 and 5. So of course we're going to do our little lovely method. I love to call it the lovely method, and we have 2 and we have 5, and we're going to draw a little table here. And of course we're going to divide through by the prime factors. 2, 3, 5, 7, and 11. And can 2 go into any of these? Yes, 2 can go into 2, leaving 1 and 5. And can 2 go into any of these? No. Can 3? No. Can 5? Yes. So you get 2 and 5, which is 1, 1. And you are finished here when it's 1, 1. And then to find the LCM, right? The LCM, it's actually equal to 2 times 5, which is just 10. Cool. So since we have this 10 now, guys, we kind of realize that we can actually make these two x coefficients 10. And how do we do that? Well, the first thing we're going to do here is we're going to multiply this equation by 2. So everything in the equation will multiply by 2. And we're going to get 10x plus 6y is equal to 42. And we'll call this equation 3. Then for this one now, guys, for the second one, in order to get a 10x here, we're going to multiply everything in this equation by 5. And we're going to get 10x plus 5 times 7 would give us 35y. That's the mistake I made earlier. And then 5 times 20 would give us 100. Cool. And this would be equation 4. So what we're going to do now, guys, is we're going to subtract. We're going to subtract equation 4 from equation 3. So we're going to literally subtract this here from everything above it. Cool. So this 10x minus this 10x would give us 0. This 35y minus 6y would give us negative 29y. And then we would have 100 minus 42 would give us negative 58. Then y would be equal to negative 58 divided by, let me write that 8 better. Oh man, I really don't like how that 8 looks. So it would be negative 58 divided by negative 29. And if you divide two negatives, you're going to get a positive. So y is actually equal to 2, right? And we can test it if we want to, guys. We can actually test it if we want to, but what we're going to do now, since we have y is equal to 2, right? So we're going to say since y is equal to 2, then we will substitute y is equal to 2 in equation 1, right? I like to use equation 1. And we're just going to put y is equal to in here, and we're going to get 5x plus 3 times 2 is equal to 21. Then we're going to get 5x plus 6 is equal to 21. And then 5x is equal to 21 minus 6. Then we're going to end up with 5x is equal to 15. And then x should be equal to 15 divided by 5. So x is actually equal to 3. Cool. So, yeah, so at the end, the answer for x and y is equal to 2 and x is equal to 3. Cool. And we solve the simultaneous equation. All right, guys. That was the method of elimination. So this method is not too bad. I think it's really simple. And what we're going to do next time now, we're going to do the same question, but we're actually going to focus on the y coefficient. All right, guys. So I'm going to clear the screen, and we're going to look at the y coefficient instead of the x. Cool. All right, guys. So now, guys, we're going to be focusing on the y coefficient, okay? And we're going to use the same method of elimination, but instead of using the x variable, we're going to be using the y variables. Cool. And we're going to be looking at these. So the first thing we need to do, guys, is find the LCM of the y coefficients. And if we find the LCM of the y coefficients are 3 and 7. Cool. So of course we're going to use the lovely method. We're going to say 2, 3, 5, 7. We're going to look at 11. We're going to look at the prime factors, and then we're going to say, can 2 go into any of these? No. Can 3 go into any of these? Yes. 3 goes into 3, leaving 1. Let's just draw this down a bit. And 7. And for this one here, can 2 go into any of these? No. Can 3? Can 5? No. Can 7? Yes. 7 can go into 7, leaving 1 and 1. So the LCM is actually equal to 3 times 7, which is equal to 21, right? So since we have the LCM being 21, now we know that we need to try and make the y coefficients for both equations 21, all right? So what we're going to do first is, the first thing we're going to do is we're going to multiply the first equation by 7, because 7 times 3 gives us 21, right? So we're going to get 7 5s 35x. Then we get plus 21y is equal to 7 times 21 would give us 140 plus 7. So I think it would be 147, right? Yes, 147. And then for the next one, for this second equation, and by the way, we're going to name this equation 3. Then for this second equation now, to get this 7 as 21, we just need to multiply it by 3, right? So we're going to end up with 3 times 2 here would give us 6x. Let me write that a little lower. Yes, this is 35, 3 and a 5. And I'm going to have 6x here. Then 3 times 7 would give us plus 21y. And then 3 times 20 would give us 60. Cool? And we're going to name this equation 4, of course. Yes, nice. And then obviously, guys, we're going to subtract equation 4 from equation 3. Cool? And when we do this now, when we subtract this one from this one, we subtract everything here from the top, and 6 minus 35x would give us 29x. This 21 minus 21 would give us plus 0, is equal to 60 minus 147 would give us 87. Yeah, it would give us 87. And then we have 29x is equal to 87. And then if we actually divide 87 by 29, the answer is actually equal to 3. So x is equal to 3, right? Then we need to find y, right, guys? So what we want to do is we want to say here, since x is equal to 3, then we substitute x is equal to 3 into equation 1, right? So we're going to put x is equal to 3 into 5x, right? 5 times 3 plus 3y is equal to 21. And then this 5 times 3 should be 15 plus 3y is equal to 21. And then we have 3y is equal to 21 minus 15. And then y is equal to 6. 3y is equal to 6. And then we have y is equal to 6 divided by 3, and then y is equal to 2. Cool? And you notice, guys, we got the same thing as if we focus on the x coefficient. So we should always get the same values regardless of which way we use. And that's the amazing thing about this substitution. The amazing thing about this simultaneous equation situation, right? So it's a very simple thing, guys. I think it's a really easy topic, in my opinion. You just have to get used to it. Now we're going to look at another method, the second method we showed earlier, which is the method of substitution. And this preferably is my favorite method. So let's look at it. Let's look at the method of substitution. All right, guys. All right, guys. So guys, we're going to be looking at the method of substitution, right? And I mentioned earlier, this is my favorite method, the method of substitution. I just really like to substitute, instead. It's just much easier in my opinion. So it says here in the method of substitution, we use one linear equation to substitute in the other linear equation for one of the two unknown values. we then solve for that value, then we can substitute the determined value in one of the equations and solve for the second unknown value. This should be second. I'm not sure why I typed an F, but this should be second, right? And let's just solve for that, let's just solve for that right now. So I'm gonna do it in this case. So the first thing we're gonna do guys, is we're gonna look at the first equation here, right? We're gonna look at 5x plus 3y is equal to 21. And what I'm gonna do here, guys, is I'm going to solve for this x, right? So I'm gonna say 5x is equal to 21 minus 3y. And then to find x, I have 21 minus 3y. All of this is divided by 5. Cool? Yes, so I'm gonna end up with x is equal to 21 minus 3y all over 5. And this is equation 3. Okay, guys? So this is equation 3. And what I'm going to do here, guys, is I'm going to substitute, all right, substitute equation 3 in equation 2. So I'm going to put this x in here, in equation 2. So I'm going to end up with 2 times 21 minus 3y over 5, right? Plus 7y is equal to 20, right? And then this is going to end up giving me, right, what am I going to do here? What's the best thing to do here? I could just multiply everything by 5. I think that's a good idea. So I could remove the 5. So I'm going to multiply this by 5, and I'm going to end up with 2 times 21 minus 3y. And then 5 times this 7y will give me 35, plus 35y is equal to 5 times 20 would give me 100. And then I would end up with 42, right, minus 6y plus 35y is equal to 100. And then if I carry the 42 over to the right side, I'm going to end up with 29y is equal to 100 minus 42. So 29y, I'm going to write it up here, guys. 29y would end up being 58. So y is equal to 58 divided by 29, and then y is actually equal to 2. Cool, just like we got earlier in the other equation. So y is equal to 2. And I actually was going to just clear the screen and do everything to show you what's up, but I don't think I really need to, right? Do I really need to? I don't think I need to. But I probably should. I think I probably should. So I'm going to clear the screen, guys, and I'm going to write over all of these stuff, and then I'm going to solve the rest of the question, okay? All right, guys, so we're going to start from here, right? And we're just going to do over this part. So we have x being equal to 21 minus 3y over 5, and we want to substitute this new equation, equation 3, into equation 2, and we get 2, right, times 21 minus 3y all over 5, right, plus 7y is equal to 20. And then in order to remove this 5 underneath here, I'm just going to multiply everything by 5, right? And I'm going to end up with 2 times 21 minus 3y. These two 5's cancel. And then 5 times 7 would give me plus 35y. And then 5 times 20 would give me 100, right? So this here now, we would end up with 42 minus 6y plus 35y is equal to 100. Then we'd end up with 29y is equal to 100 minus 42. So yes, we'd end up with 29y is equal to 58. And then y is equal to 58 over 29. So y is equal to 2. Cool. So that's where we stopped before. So if y is equal to 2, then we can substitute y is equal to 2 in equation 1, right? So we're going to say 5x plus 3 times 2 is equal to 21. And then we get 5x plus 6 is equal to 21. And then 5x is equal to 21 minus 6. And then 5x is equal to 15. So x is equal to 15 divided by 5. And x is equal to 3. Cool. So we end up getting the same thing just like when we use elimination. And great. And the thing about substitution, guys, is of course you can focus on using the y method with substitution. Um, but yeah, you don't really have to do the other way. You can always just use the x variable. Yeah, you can always just use the x variable. But we could also use a situation where we focus on the y, right? Um, cool. So we have x is equal to 3 here. X is equal to 3, so that's the answer. X is equal to 3 and y is equal to 2. Cool, and that's our answer. And cool, so let's move on. Let's do some more examples, guys. I think that might be a good idea. All right, guys, so we're going to be looking at another example. And in this case, guys, we're going to substitute, right? We're going to use the method of substitution. But for this method of substitution, guys, we're gonna focus on the y variable instead. Cool. So let's look at this. So the first thing we're gonna do, guys, is we're going to take equation 1, 3x plus 5y is equal to 21. And then we're gonna solve for y, right? And we're gonna say 5y is equal to 21 minus 3x. And we have y is equal to 21 minus 3x all over 5. Cool. So this would be our equation 3. Yes, that's our equation 3. And now, guys, of course, we want to substitute equation 3 into equation 2, right? So we're going to put this y is equal to 21 minus 3x over 5 into that 3 here, and we're going to get 2x plus 3 times 21 minus 3x all over 5 is equal to 13. Cool. And because I want to get rid of this 5, guys, I'm going to multiply everything by 5. So this would end up giving me 10x, this 5 times this 3x and everything here would just cancel out this here, and I would get plus 3 times 21 minus 3x is equal to 5 times 13. How much is 5 times 13? 5 times 10 is 50, and then 3 times 5 would give us 15. So this would be 65, right? And then we end up with 10x plus 3 times 21 would give us 63. And then 3 times minus 3 would give us minus 9x is equal to 65, right? So we're going to end up with a x is equal to 65 minus 63. Because we carried the 63 over to the right side, and x is actually, we end up with x is equal to 2. Cool, which is pretty simple. So for the next one now, we're going to say since x is equal to 2, then we substitute x is equal to 2. Let me just fix that too. We substitute x is equal to 2 in equation 1, right? So we're going to end up with 3 times 2 plus 5y is equal to 21. So we're going to end up with 6 plus 5y is equal to 21. and then 5y is equal to 21 minus 6. So 5y is equal to 15, and then y is equal to 15 over 5, and y is actually equal to 3. Cool. So the answer, y is equal to 3 and x is equal to 2. And yeah, we're focused on the y variable. All right, guys, for the substitution. And guys, it was really simple. I think this topic is very simple.